Well, hi, good morning. Thanks for coming and joining me in my shop here while I go. Well, I don't know what's going to happen. I'm going to show you what I figured out last night, and maybe in the course of doing that I'll sort out what to do next on this radio. So what you got in front of you here is a diagram that I've drawn up on this page you'll be looking at, and the actual radio. You can kind of see my other camera just out of view here. Okay, I want you to get a perspective here so you understand what's going on. So this camera is looking down in the back of the radio, which more or less matches my diagram. It depends just how critical you want to get. So this is the view from the chassis camera, and then this will be the view from this camera. Okay, yes, on previous videos I have commented about the quality of other people's schematics and diagrams, and I've been fairly critical because, after all, I was a drafting supervisor in an engineering department for a while. So now you can see why all the professional draftspeople were not impressed when I was their supervisor. Look at this. So I've made this diagram to more or less match the layout of the radio, but as I drew it, I started over in this area. I had to incorporate more and more of the radio chassis to follow the wires because they went places I didn't expect. So why have I done this? Just to make it absolutely clear, there's two tubes in the back of this set. I've got them pulled out right now, but they're back here. There's one sticking out, the other one's sticking out right beside it. They're sitting on my bench right here, in fact. These are the tubes that have come out of it. At first glance, they looked like two identical tubes. I figured push-pull output, voila. But I started noticing parts are missing. There's no transformer for push-pull. And eventually things got stranger and stranger. If you watched the last videos, you've encountered some of the strangeness with these two tubes. So I wanted to settle it down by drawing out a diagram of what is really going on in the radio. So let me try to get you up on the. In the end, this is going to be very simple. But at first it's going to be a little bit confusing. So these are the two output tubes in question, the two tubes that are sitting up here on my bench, just behind the speaker here. Okay, 6F6 and a 42. This is an 8-pin tube with a key pin, if you like, a plastic center keyed pin here. The 42 is a 6-pin older tube. It's keyed by the size of the two heater pins. They're fat, two heater pins here. So, but the glass globes look identical. So at a glance, they look like two identical tubes, but they certainly aren't. Oddly enough, electrically, they are identical. So if you took, maybe I'm answering my question right now. So if you wire this appropriately for a 42 or were to wire this appropriately for a 6F6, either one would work. But that's not what's been done here. That's not what's been done. Yeah, maybe that's part of the answer. So let's take a look in the back of the radio now. Sorry, I'm thinking as I'm doing this. That's always a dangerous thing. So here's the two tube sockets over here. And the real question is, even at a glance, what's going on with this one? This is the 6F6. This is the socket the 6F6 was in. And I noticed the last time I looked at it, there were only two wires coming to it. There's just two wires come to the socket, and the tube lights up. So those two wires have to be heater wires. So as far as I can see, just from looking in here, the heater seems to be wired. But there's a couple of resistors here. Well, what is this all about? Yeah, okay, and that's about all you need to see in the back of the radio right now. Let's go back to the diagram. I'll show you. So here's the let's call it the mystery tube, the 6F6. The two wires, here they are. The two wires come out. I thought they were going to this tube, but they aren't. They actually go by. They're twisted around each other. They go all the way across the radio to the far. Well, maybe not the far side, but more into the middle of the radio, where they connect to heater terminals for this tube, which is then connected to the heater terminals for this tube, which is then connected to the heater output right from the transformer. So what I'm saying is that this is a heater supply wires. That's all that exists on this. The purpose of these resistors, 50,000 ohms here, 5,000 ohms there. I have no idea. Even though the 6F6 is plugged in here and its heater hooks up to the right pins and the heater does heat, there's nothing else going on with this tube. How can there be? There just can't be anything else. There's no B plus brought to it. Nothing. So this raises a lot of weird questions, like why did they run these wires all the way back to here? Why didn't they just pick it up from the heater here, right here? See, this tube has a heater, of course, and here's one leg goes to the chassis, the other leg back to the same point over here. So exactly why they would run, let's look in the radio again just to show you how curious this all is. So here's the one we're looking at. The two heater wires are kind of tucked in the back here, and you can't see them, but they run around just under the apron here, and then they come out and they connect. One connects here, the other one carries on, connects over here. If I got it right. You know what, I probably don't remember this right now from last night. So that's what it amounts to. This has a heater supply, nothing else, a couple of resistors between pins. I have no idea why. And so while I was in there, I started looking at a few of the other connections, especially down here in the output tube. So let's go back to my sloppy diagram here. So now, if you look at the output tube here, we'll start with pin number 1 and pin number 6 are the two heater pins. I already showed you how it gets its heater power. Fine. Next one along, pin number 2 is the plate. So plate has one wire going over here to a terminal strip where I believe this is the point at which B plus is splayed out into the radio. So there's a number of terminals here. These two wires are not connected. There's a number of terminals along here. So this plate, the next one is grid number 2, which is the screen grid. So it's also picking up its voltage from this terminal. So probably a resistor network over here or something. I didn't go any further over here. But you want your screen voltage to be a little lower than the plate voltage. So that's probably what's going on over here. Next one is the actual signal grid. You can see a large resistor here to ground. So that's the leak resistor, leak off any grid charge. And then you see a wire come into a capacitor and then heading off this away. I didn't bother drawing it. Heads over into these tubes, no doubt. Picking up audio. It should be picking it up from the I think the 6Q7, if I remember right. So we can take a look at that capacitor right there, which is a little bit curious too, but I think the story is coming clear to me now. So here's the capacitor, and you see it's just floating here. And it's made this, that's really kind of weird. Something else that you can see on camera is this splash of solder here to which nothing is connected. And that's a little odd. And there's another splash of solder down here. And again, nothing is connected. You can see cut wires. So, you know, how do you ever come up with a story to explain that situation there? I don't know. I don't know. I don't know how to explain it exactly. The fact is, in this radio, this tube socket, it means nothing. You put a tube in it, it lights up, it means nothing. No reason to put a tube in there. The only one that means business is this one, which appears to be wired appropriately. Go back to the diagram here quickly. So you can see that's the signal coming in to the grid. The signal coming out of the plate is traveling up here. This is my poor diagram of the speaker plug that's on the back of the set right here. when you look at this, this is a little bit of a mystery too. This is where I ended last night, and I didn't really continue thinking it. I just noticed some things. So there's 4 contacts in that plug. If you look on the actual speaker plug, you can see there are 4 pins on it, and there are 4 wires heading up to the speaker. The speaker with a field coil or not a field coil. We still don't really know what's happening with that speaker. So here we see a signal coming in from the 5Y4, which is the rectifier, on a red wire. So this is the B plus coming in. It's going up to the speaker to drive a field coil. No, it isn't. It's going up to the speaker to go through the output transformer that's up on the speaker, which you can see right here. Okay. So this goes up through the output transformer, back down, and you see that it's actually the plate output. Okay, so I'm a little confused. I don't know what this wire is now. Oh, you know, I may have made a mistake when I made this diagram too. So, not to sweat too much about this one right now. I just wanted to resolve what is going on with this. My resolution is this is a pile of baloney, and I will ignore it from now on and carry on. I just leave it as a big question mark about why this radio has this stuff in it. I don't know. This all seems to be correct, except for this. Here's the cathode. I didn't bother even drawing in the connection here on pin number 5. Let's take a look at that. I guess I just didn't quite finish the effort here. So number 5 is let me get something to point with here. Okay, so this is number 5 here. Number 5 has, of course, the cathode resistor and the cathode bypass capacitor connected to it, and this terminal here just runs along to ground. It's grounded on the chassis up here. So it all makes sense. So that's a cathode. Let's just check that plate wire again. So while we're here, so this is the plate wire. That is, you know what? That is not soldered properly there. That is loose. That is loose on the connection. Oh, this whole thing's loose. And the other ones are loose. You know what? This is a different style of course. I'm not finishing any of my thoughts here, am I? Okay, slow down. This is a different style of material here from every other connector in here, from every other tube socket in here. This one's different. This is loose. If they could have converted this radio, some kind of kit, converted from a battery radio to a plug-in-the-wall radio. So then you go through the kit, and when you're done, you've popped out the battery connector that was here and popped in a different output tube socket, strip this one clean, almost clean, stick the high voltage wires, all the wires that were coming here, onto this, move these all around to suit, end up with stuff like this happening. Oops. And that's why you've got this resistor, which is a little weird looking. Like, it just doesn't look like the other components in the radio. Maybe while you're in here, you change some more capacitors so they all end up looking like this one. This is the one you had to put in to make the change, but you went ahead and changed all the other ones. Maybe. Whoever you are. Who are you? Because they all look like they've been changed out. So they could have been paper capacitors in there, and you change them out with the ultra modern molded capacitor with an expected life of 16,000 years. It turns out to be 16 months. So what else is happening down here? So here's the wire, this one here, it's coming up. This is just a grounded terminal. It's just grounded terminal here. And I have this wire here. I think this is one of the heaters here. So heater, grounded. No other surprises. That's about it. That's about it. Let's go back to the diagram now. This tube has a plate, has a grid. No, it's an output tube. Output tubes work really hard, so they want a lot of current flowing through the tube. So they have a heavy current, varying current going through the transformer. Current is needed to make the transformer work properly to drive the speaker. So these are hard-working tubes. Output tubes are hard-working tubes. Big flow of electrons going through them. This usually uses a higher plate voltage, or the highest plate voltage they can get in the radio. They put it on this tube because the higher plate voltage, again, draws the current through the tube, heavy current. The problem is with the higher plate voltage you get much more energized electrons striking the plate because they're getting more electron volts applied to them, so they're moving at a high speed. They strike the plate and they bounce. They knock others out and they bounce. So if you're going to have a hard working tube, you probably need a suppressor grid to push back the electrons onto the plate. And I'm pretty sure that's what's right here. So you see cathode, this terminal, cathode and suppressor grid here. So then there's a screen grid. There has to be a, doesn't have to be, but you would want a screen grid, and here it is. I don't think these pins are connected to anything. Let me look and see. Let's try this out. Screen grid is number 3. 1, 2, 3. You notice between the rivets there's 3 and 3 in a nice pattern. So from looking at it with my eyeballs, I should be able to spot this pretty easy. And the reason I say stuff like that is I find it too easy to get turned around and confused. Okay, so I don't know how well you can see this, but it's under this capacitor. It's this terminal right here. And these wires, these big wires here, they're pretty fuzzy. Fuzzy makes it hard to see. It's very, very tricky. You have to feel them more than see them. Okay, so off the screen is this reddish wire back here, this one here, and it's coming back to this terminal of high voltage, this thing here, which I believe is basically a terminal point for high voltage. Look, there was a red wire here that's been cut away. You know, they cut away the original red wire and hooked up. This is a new one. It's different, right? It's got that pattern to it. Whereas the original ones are just rubbery red. This one's got cloth covered pattern. This is probably a new wire. I think I'm figuring out what they did here. I wonder if you couldn't buy a conversion kit and then sit inside your repair shop and offer the opportunity for people with this radio, expensive radio, battery operated, to have it converted. So you bring it in and all kinds of stuff happens to the radio and it goes out converted as an AC radio. That's my story at this point. I can't come up with a better story for how this all... And so originally what was in here was the battery connector plug cable. And this was the output tube. Why they didn't carry... I don't know. Who knows why they didn't carry on with the same tube. I don't know. Seems kind of weird to me, but that's my best story. So where else am I at here? So I've got this wire, which is not Certainly doesn't appear to be soldered. I think I can get that right on camera. It's usually my own soldering that I'm being critical of. Let me focus here just a bit. Hang on. Okay, a little extra light in there. There, can you see? That does not look... No, listen, you can hear it. It's completely loose. So we got one. So that could have been the cracker. That could have been all that cracking we heard. It could have been that. And we have this weird arrangement up here. You solder it on this end. Maybe you forgot both ends. Weird stuff. Okay, I think I beat that to death. I can't imagine I'm going to extract any more understanding out of that at this point. So what are we going to do here? I still have to make a decision about, really going ahead with this radio. It still has a pretty sick speaker. Very sick speaker. Make the radio work beautifully. Speaker. Yes, speaker. I never finished that. Okay, let's carry on here. So 4 pins, this connection and this connection. Let me point it like this. Can you see this? This is not good for me to hold this up. Let me put it back. So of the 4 pins, these 2 are busy conveying plate current up to the transformer on the speaker. What are the other 2 doing? This one goes to ground. This one is cut. You can actually see the remnants of the wires here in the solder. It's cut free. There's nothing going from it. So that really means 1 wire of the 4 going to the speaker is doing absolutely nothing. The other wire, another wire of the 4, is just carrying up the ground from the chassis. Now these 2 wires are conveying the signal into the transformer. So that is screaming out permanent magnet. Think about the original, one of the reasons you want to have a field coil speaker, the main reason was that they couldn't create permanent magnets cheaply strong enough to do the job. So they use electromagnet to do the speaker job, and then utilize the electromagnet as the field coil or as the choke coil in the power supply. It's a very tricky deal. I think it even has some bucking benefits if it's done right. So for that to happen, you have to send 4 wires to the speaker. 2 from the power supply heading for the field coil, and then 2 heading either to the voice coil or to the output transformer, depending upon where the output transformer is located. In this case, it's up on the speaker itself. Cut. So there was a wire there. So this suggests to me something that doesn't make any sense at all. That there was originally a speaker in there with a field coil, and they were using the field coil as part of the power supply. But originally this thing was battery operated, so the power supply doesn't need a field coil, nor would it want one. You don't want to try to energize a coil from a battery. That's a waste of power. So in a battery operated radio, it almost certainly has a permanent magnet speaker on it. Well, I've just gone around in a big screwy circle on that one. So why bother with 4 wires on this cord? Why send 4 wires all nicely up here? Just to confuse me? The only answer I can come up with is yes. Only designed to confuse me. could just see Bill and Fred in the design office back in 1928, and one of them saying, "Man, I tell you, when this radio gets in the hands of somebody in the year 2018, wow, they'll be blown away." 90 years later. Okay, so my goal at this point, better say my objective. My objective at this point is to get some sound to that speaker so we can assess that speaker. I'm trying to get the sound to the speaker through the radio. We can also assess the radio then. But so far, the radio has been such a bad behavior that it really hasn't sent anything to the speaker yet that really helps me assess the speaker. My initial impression of the speaker is it's a pile of crap. And I don't think it's going to change. I think once I get this, if I get this going better, it's only going to prove more and more that the speaker's in big trouble. So, if that's the case, if the speaker's in big trouble, but it's not a field coil, that means any speaker, almost any speaker with a transformer mounted on it is going to work in here. And then there's all the problems of fitting another speaker, and I don't have another speaker anyway. Do I? One more, do I? I don't know. So I don't want to think about that. That's a hard road to go down with the speaker here. It's a hard road. It's over here. I keep pointing at it. So I guess my objective here is I have two options here. One is get this radio working well enough to get something going to the speaker to judge the speaker, or set the radio aside, try and test the speaker more directly by feeding signals into it, right into the voice coil up here, and listen to really what this thing is doing. In fact, it's really not too hard to hook up a music source or something to the speaker and listen to it, as opposed to a tone from a machine. Pretty sure if I plug this guy back in, we're just going to hear either nothing or some more crackling. Okay, so that going at it on a different angle now. Just notice there's a wire cut right there. See, there's piles of solder here with nothing attached to it. Wow. It's really so here's another one, another piece right here. Great big piece of wire here. Is that the leftover of this? Put this capacitor in, just kind of wrap the lead around and whacked it with solder here. Well, getting a signal out of this radio that's suitable to check the speaker is a tough go. If the speaker's absolute crap, there's really no reason to fix this up until I solve the speaker problem. I could put a lot of effort into this, still have this not working, still don't know if the speaker's good. A lot of effort, maybe no benefit coming. The radio cabinet, as I mentioned before, is in trouble. The glass is missing. Some knobs are missing on this radio. Let's try testing the speaker independent of the radio. I think we can pretty certainly go another step there. Radio over here. Now, yeah, permanent magnet, that's for sure. Now we can't just feed a well, maybe we could actually feed a signal right into the leads here, because it's going through a transformer. You know what? We could try that. Doesn't matter to me how I get the signal onto the voice coil, really. So let's get let's turn this guy on here. Whoops. To know for sure we're getting some sound. just grab a test speaker here. Where are you? There it is. In all honesty, it just fell out of the shelf without me seeing it. That's my little test speaker. My test speakers, the voice coil lead's broken off there. I think that's going to work. There we are. Now, which of these leads? There's two fatter ones, two thinner ones. Let me look at the radio chassis. I would say it's the two. I think it's the two fatter ones I've used. Let's try it out. We're going to just try different combinations here. There we are. Okay, now, if it's going to be crappy, it's going to sound crappy with lower frequencies at a higher amplitude. It's not so bad. Let's go a little lower. Really hard to tell with these pure kind of tones. Not sounding very pure to me. So I think the next thing, what we got to try to do is put some music through this thing. That might be a little trickier. I can feed my signal from the signal generator right through the transformer. Don't think I can do that with a regular radio output. My easiest signal to steal here would be from what? Okay, I gotta stop and put something together here. Okay, let's give this a go. This is coming from my little transistor radio. It's just way up here. So it's just plugged into the earphone. It's not really the best place to take a signal out, but for the sake of doing this, it's probably good enough. So we're going to take the signal out of here. First, we're going to feed it into the little chunky speaker here. Maybe turn it up.
But nevertheless, if he was drowning, I'm sure a lot of feelings and guilt and shame.
So that's full blast.
But yeah, at that point in my early 20s.
So sometimes headphone outlets on radios have resistors to pad them a bit. Maybe this one does. Now I'm going to hook it up right onto the output transformer input. Because I think that's what I'm doing here. So it's a very totally inappropriate way to do this, but let's see what we get. Didn't hear anything. Turn it up here.
Those moments were not easy. I mean, even
they
if
wouldn't be easy if you were watching a heterosexual parent do that.
Absolutely not. Absolutely not. It has nothing to do with the sexuality. It didn't for me at all. It's just.
What the heck are they talking about here? Okay, so as interesting as that might be, I haven't proved very much because I really need a stronger audio. You know, a little bit of weak audio, you might get away with it with a piece of crap speaker. You might get away with it as soon as you're trying to get that cone going. So I'm going to try to hook this instead of through the transformer. Let me turn it down here. It's actually turned up full tilt. We'll try to see if we can't get this right onto the voice coil. Okay, that's two suspicious connections right there. That's almost certainly to the voice coil. Put this like that. Put it like that. Put it like that. There. There we go. Okay, now try this here. Again, I don't really care how I do it. I just want some loud stuff coming out of this speaker. Let's try that. A little louder. It's not music, so this isn't the now the radio signal itself is distorted a bit right from the signal. It's a little bit hissy crackly. Let me tune the radio into something a little better and louder. Maybe up this way.
The door is on the way. We've got a transport truck trying to climb a very small hill.
You need the Rock 95 Storm Watch. We'll clear the way with the best information on driving conditions.
Listening now.
Go to rock95.com for up-to-date Storm Watch details.
From the Rock 95 Weather Center, squalls and watches event.
Installations, closures.
I think it's terribly distorted.
The Rock 95 Storm Watch is brought to you by St. Hans Recreation of Barrie, making winter fun since 1991.
Rock 95.
I get it. You needed the money, so you took out a payday loan. Problem is, now you can't repay it,
Payday
but I'm
loans.
taking out another payday.
Yeah, you can go to lots of places in towns or cities like the one I live in, and you go to an intersection on all four corners. There are 4 different payday loan companies. Okay, not a loud enough signal yet. I'm getting there, but it's not quite enough. I need another. You know what I could do now? I can run the signal generator right onto the voice coil. Why don't we try that? I can pummel it a little more. Okay. Yeah, now that should be a nice warm, yeah, like I can imitate it. It's got a terrible buzzy sound to it. Sounds more like a musical instrument, eh? Bad everywhere. I don't know if I'm really proving anything here yet. I really do need a powerful I need a powerful source here. Somewhere in this shop I got something. Okay, still haven't found another sound source, but I'm thinking of what more can I do with what I've got here. Well, that's not that bad. I mean, it still sounds buzzy in here. Oh, you know why? Oh my gosh, I never noticed. Square wave. Oh, this whole time I've been feeding a square wave into here, which of course is going to sound buzzy. Now we're cooking. Okay, so this frequency is around 400 hertz. Yeah, that sounds like 400 to me. Let's go lower. 200. Something happens right in here. Go higher. Ooh, produces lots of highs. Way low. Something resonating right in here, right around the 200. Okay, that's a little unfortunate because lots of program material has 200 hertz stuff in it, even our voices. But that's not bad. That's not so bad. You know what? That's good enough for me to go back to the radio and put more time into the radio. I would really like to hear. I'm going to continue to try to figure out how to get some music to come out of this thing. Okay, I think I figured something out. Dragged out my Heathkit amplifier I built back when I was in college. This amplifier I used to drive a signal into a closed-circuit FM radio station with multiple studios cast throughout a high-rise building. What? Rewind that and play it again. I put together a radio station in a high-rise building with 700 university students living in it that had 7 studios throughout the building, just ordinary students with their ordinary stereos and one of these. And this fed an audio signal to a centralized transmitter through the building wiring. I won't go into it any further than that. Better turn these guys down. Okay, so I'm going to feed into here a proper level signal from the same radio. This one. But let's get a voice on that.
The murdering Toronto woman Laura Babcock will be sentenced today. A jury found Dylan Millard
not very good reception.
First-degree murder in December.
Okay, hang on a
Millard
second.
previously convicted of first-degree murder after killing and incinerating Hamilton man Timbo.
Okay, now I turned down the volume. That just turns the volume down on the speaker of the radio. There's still a audio signal at the end of the wire. Where's the end of the wire? Here it is. Oh, plugged in the amplifier. Turn on. Guess we need to plug it in. Here. Plug it in. Yeah, quite a few videos ago, I actually had a cassette tape of some of the program that was broadcast on the FM radio station I'm talking about. Yeah, it was FM. Here we go. Okay, I'm going to turn it up. Okay, now we got some sound.
Adaptation.
This is Walter Cronkite on the Greenland ice cap. Beyond the horizon lies the North Pole. Soon, under this ice and snow, some 100 men will be able to live in warmth and comparative comfort. While above them the temperature drops to 70 degrees below zero, their nuclear-powered frontier home will be Camp Century, the city under the ice.
CBS News legend Walter Cronkite reporting from one of the chilliest points on many frontiers of the Cold War. At the time, the frozen U.S. military installation was portrayed as a less than threatening research base. Here is how the U.S. Army described the plans for the camp in a documentary.
A system of 23 trenches would be dug into the ice cap and then covered with steel arches and snow. Branching off the main communication trench will be a series of lateral trenches housing complete research, laboratory and test facilities, modern living quarters and recreation areas, and a complex of support facilities.
American war planners designed Camp Century, however, to play a potentially devastating role in any thermonuclear exchange with the Soviet Union. Its secret purpose was to house 600 ballistic missiles armed with nuclear warheads. While those missiles were never actually hidden in the ice, the base stayed operational until 1967. In the years since being abandoned, snow has buried it even deeper, which brings us to another segment of our project adaptation, because now scientists are warning that climate change could melt all that ice and snow and eventually expose Camp Century, and that could create all sorts of political headaches over who is responsible for dealing with the toxic waste that would surface from the melting depths. Jeff Colgan is an associate professor of political science at Brown University. He is the author of a report looking at the political implications of the impact of climate change on U.S. military bases. He joins me from Providence, Rhode Island, and I'm also joined by Mike McFerrin. He is a research glaciologist at the University of Colorado. He has studied the melting ice around Camp Century. He joins us from Boulder. Hello to you both.
Thanks for having us on, Emery. It's a pleasure to be here.
Well, Jeff Colgan, let's start with you. So if Camp Century was part of a larger U.S. Military plan with these 600 ballistic missiles, what was the actual plan?
So the concern was that the Soviets could attack the U.S. bases in Europe and leave the U.S. without the ability to retaliate with nuclear weapons.
Speaker Cohen's in contact with this.
Not only did they want to have up to 600 nuclear missiles in Greenland, they
this
wanted
thing.
to put the missiles
right there.
on a railway, a 4,000-kilometer.
That's why the cone has a bump here.
Continuously moving in ice tunnels cut into the ice sheet of Greenland. And that way they would be very difficult to detect by the Soviet Union and very difficult to take out, to attack in any way. But,
some clearance there, but not much.
James Bond villain kind of,
I don't think the speaker would move enough to bump it, actually.
Did they actually build missile launchers? Like, did they actually launching pads to do that?
No, they never got nuclear missiles to the base, and they cut quite a length of tunnels, but they never had enough to really...
What I'm trying to determine is the voice coil rubbing inside here, or is it something else?
Today, when you look at it at Google Maps, you get the dot, and it's all white. You have to keep going back on the map to see where it is.
Yeah, it's very isolated territory. It's 150 kilometers east to Thule Air Base, which is the...
How they actually constructed Camp Century under the ice?
It's 8 to 10 meters deep.
You know what that is? That's a huge... that's a problem with my amplifier.
Essentially, and then covered them. So you had a couple of entrances to the tunnels.
So
and then
that sound, that's an interesting test in itself. I'm discharging a whack of DC into the speaker when I do that.
The building.
It's causing the speaker cone to move quite a distance relative to what it's doing when it's making sound. It's moving into a position it doesn't normally get into while we're listening to it here. And what's it sound like? It sounds like somebody rapping on a loose window.
There. Would do these large traverses with these.
That's a hint that if you put a strong signal into here, strong sound like you're playing music with lots of nice bass in it, this thing is going to just sound like a rattle trap.
And I assumed it would remain buried forever. Is that right, Mike?
Well, that's the big crux of it now. Yes, at the time they assumed it would be quote unquote preserved for eternity. Anything that was left behind would.
What they're talking about up in Greenland, I watched there's a video on this, and the video is produced by the American government, so it's not a crazy documentary meant to scare you or something. It's actually a proud video about this under the ice secret military base that was built in Greenland by the United States after the Second World War. I guess in this story what I've picked up is, and they didn't talk about this in this film, of course, the government film is not going to talk about what the purpose of it really was, because the government film is part of the propaganda machine to cover up what it really was. And what they're saying, it was supposed to be a nuclear weapons base, they just never got any nuclear weapons into it. So, hey, makes you wonder what else has gone on. I mean, the United States isn't the only country in this world. There's another, 100 capable countries of doing stuff. Who knows what's gone on in this world? Okay, maybe there's a secret military base right under my house. Okay, now focusing on the situation here. This definitely is not going to work well. It's as definite as I can be at this point. Fix the radio all I like, it's going to sound horrid coming through the speaker. So why would I bother continuing with the radio that's already in bad shape? The cabinet's in bad shape. It's missing knobs. I think at this point what I got to do is set it all aside. I hate to say that. Set it all aside. Think about how I'm going to deal with this speaker. Maybe I got another one kicking around somewhere. I don't think so though. Maybe I got something I can use. Maybe I can separate the transformer here and utilize it on another speaker. You know what? I think I have a brand new speaker roughly this size, but it's NOS. It's new, but it's not. But it certainly doesn't have a transformer on it. So I got to think about these things before I invest, my life's effort into a radio that is never going to work well. It's never ever going to work well. I got to think of alternatives. Thanks so much for watching, and in the meantime I'll find another project to work on, and there's a fantastic radio coming my way in about a week too. So thanks so much.